Hello students. Um, Today we are going to see the logical equivalence. How we can do the what is meant by logical equivalence and also the laws of logic. I am going to explain you today. This is the continuation of the previous classes. So we are in the chapter logic. So far I had explained what is meant by logic and what are the connectives used in this logic, and also in the previous class how to construct the truth table I had explained, and also the tautology and what is meant by tautology and contradiction. Okay, today we are going to see logical expression and laws of logic. So what is meant by logical expression? Two logical expressions which are composed by the same proportion are logically equivalent if they have the same truth table. Okay, so if one logical expression and the another logical expression have the same truth table, I can say that two logical expressions are equivalent. So you see here, show that the logical expressions A as negation of not P and not Q, and B as P or Q are logically equivalent. So I will explain you by doing this one. Even though here it is explained here, I will explain you. Okay, as usual, we need to take the P value. Sorry. Okay, first we need to take the P value and Q value. Okay, and then we need to take the negation P, negation Q. Yes, they have taken. And then we need to take the AND for negation P and negation Q. AND means for if it is both are true, then only you will have the true, otherwise it become false. Okay, then A is the negation of not P, and so we need to do the negation. If it is false, it become true. False, it become true. False, it become true. If it is true, it become false. For B, we need to take P or Q. So P here, and we need to take the OR. For that, if true comes, you will have true. So true, 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 where false. See, both the one have the same truth value. Okay, both the truth table are same, so therefore I can say both the expressions are equivalent. It's very easy now. You can do the homework. Okay, this one also I can explain you. It's very easy. You can take it as a homework. You can do by yourself. So I have given many problem as a homework. You can sit and do at home. Anything do you want to explain? I will explain it here. Shall we check C? Okay, so for the C I need B, P and Q. So true, 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 false, false, true, then false, false. I need to do if and only if. If and only if both are same truth table, you will have true, otherwise you will have false, like this. Then negation of P if and only if Q. So for this the negation is false, true, true, false. Okay, this is one truth table. Another thing, I need to take the negation Q. So what is negation Q here? False, true, false, true. Then P if and only if negation Q. P is here and we need to connect with the not Q. Okay, both are same, then you will have true. Here it is false, true, true, false. By seeing these two look same, so therefore the two logical expressions are equivalent. Okay, shall we do one more problem? E. I will rub it. I don't know whether these expressions are equivalent or not. By checking I can confirm that. So PQ I needed, then I need PRQ. PRQ, if anything is true, you will get true, otherwise it is false. Then I need to take P and PRQ. P and PRQ we need to take. If false comes, it becomes false, otherwise it is true. False, false. Okay. Then I need to go for P, so compare it with P. See, it looks same. P and PRQ remain same, so both the expressions are equivalent. So please check like this. If it is not same, you can say it is not an equivalent expression. So today I had explained you, so far I had explained you how the two proportions are equivalent, compound proportion. So proportional equivalent proportion I had explained so far. If both the expression have same truth value, then the both expression logical expressions are equivalent. The next one we will see what is in the laws of logic. So you need to memorize all the laws which is given in this table. So the first law is called the equivalence law. If P if and only Q, then P implies Q and Q implies P. Both the sides are true. Then implication law, if P implies Q, then not P or Q. Okay. Commutative law, you need to shift the place, then it will be equivalent P and Q, which is equivalent to Q and P. Then see, all the laws can be written for and also for or. Okay. By changing the and as or and with the or, you will have this another commutative law. Associative law means grouping. If you are grouping P and Q here, you need to group Q and or here. So likewise you can interchange. Distributive law, so likewise you need to multiply P and Q or P and or. Identity law, is same as P and true means 0. So you will get P. If it is P and 1 means you will get P. Okay, that's the meaning of that. So 0 means false, 1 means true. So that's why you are getting both the one as P. And idempotent law, if both the one are same, you will have P here. Okay, for and also for or. Inverse law, if one is P and another one is negation, you will have F. For and for or, you will have true. Double negation law, you will have the same thing. Annihilation law, if P is with F, you will have F. If P is with true, you will have true. De Morgan's law, you know that negation we need to put it for each one and change that and as or. That is for negation. De Morgan's law. Absorption law means if you are having same proportions like this, the same proportion will come as an answer. Negation law, if negation of true, you will get false. Negation of false, you will get true. So please memorize all this law, then only you can solve the problem. You will have one example. Prove the implication law by constructing the truth table. What is meant by the implication law? What is that? The truth table of P implies Q and not P or Q. P implies Q is equivalent to not P or Q. That one I need to prove. That is the implication law. That is, we need to show that both the truth table are equal. So first P implies Q, you know already. This is P implies Q. So next thing we need to take the negation P and take the or. See, both the one have the same truth table. So therefore both the expressions are equivalent. So thus we have proved the implication law. The next, likewise you can prove the annihilation law. Take it as a homework problem. We need to simplify. Another type of problem is we can simplify this expression by using the laws of logic. Okay, but they have given the answer. Anyway, we will check whether we are getting the same answer or not. So P and not P or Q. So we can use the De Morgan's law to distribute this one, distributive law. Yeah, De Morgan's law, that's the one. So P and not P, or P and Q. P and Q, I think so. This is the distributive law. It's something we have written it wrong. This is distributive law. Then you can use the P and not P is the negation inverse law. So I can replace as false. Then by commutative law, you can interchange the place like this. If it is identity law, if it is 0 here, you will have P and Q, no? That's why. So now I simplify the given expression as P and Q. So without knowing the law, we cannot simplify it. So you should be thorough in that law. The next thing, simplify the expression, this one. See, for that we can apply the De Morgan's law here. Okay. Oh, first thing, I cannot apply the De Morgan's law straight away. First thing, we need to simplify the bracket and then go for the De Morgan's law. Okay. First the bracket. So in bracket they have shown the implication. For the implication, you need to take the negation of the antecedent and then keep that consequent and put or inside that. That's the formula, no? It is P implies Q means, which is equivalent to not P or Q. So that's why they are taking the double negation here, or Q they have kept it same. After applying the implication law, the double negation becomes P. This is double negation law. Then we need to go for the De Morgan's law, that is apply the negation inside and change that or as and. Okay, change the or as and. So negation P and not P, we have got it. Then apply the distributive law here. So P or not P and P or not Q. After applying the distributive law, so we are getting the true here by inverse law. Then after using the inverse law, I am using the commutative law to interchange the place. Then using the identity law, you will get the same value here. Then you can apply. See, this is same as the implication law. So you will get negation P implies negation Q. So this is the simplification. See, after you got the answer, you can check whether both the expressions are equivalent or not. For that, you can draw a truth table and check whether you are getting the same truth value. If you have made any mistake in between, you can identify at last. Okay, that's all this problem. Next thing, show using laws of logic that the logical expression P and Q and not P is a contradiction. Contradiction, you can show it through truth table also, otherwise by this laws of logic. By commutative they are interchanging, and by the associative they are grouping like this, and you can use the inverse law as false, and then you can use the commutative law to interchange, and at last you will get the false. Therefore it is a contradiction. Another expression, tautology. Tautology, you should get the truth value at last. So they have used in the many laws, and then at last they are getting the result as T. So that shows that it is the tautology. So this is the homework for you. Please use the logic laws to simplify the logical expressions. Take it as a homework. Okay. So I have explained you today how to prove the logical expressions or two logical expressions are equivalent, and how to use the laws of logic to simplify the logical expression, and also to prove whether the logical expression is tautology and contradiction. So To prove tautology and contradiction, you can use both the method by using the truth table and also by laws of logic. Okay students, today's sections are over. If you have doubt, you can ask me. See you. Bye bye.